Okay, so we have our section and now the match. I will do that with the user interface, and then we will see how the commands look like and how we change some parameters in the commands in order to have a script that is better for future processing. So here on the mesh tool, I'm going to select the line, and I can just pick these, which would have the same number of divisions. So I click in OK, and then we define that this is going to be 4 divisions for saying something. We apply, and then we have those lines already matched. Then this one, this one are going to have also the same number of divisions, which maybe could be something like 10. We click in OK. Mesh to line. Now we will define the division of the web, so all this that you see here, and we can just define the web divided into 3 sections. We click in apply. Then the web itself, the length, we can divide the web itself in 20, for example, and then we go into this part, which is a little bit more complex. This one would have the same number of divisions because they follow somehow this pattern there, and we are going to divide them into 3 elements as well. You see how the rolling part looks when that is divided into 3 elements. Not so nice, but it does the job a little bit. And then we have this part here. We're going to use 3 elements as well here for the upper and bottom side. Okay, and also 3. And we apply, and then we can just close this. Now we save the file and we go to the script for C to check how this is defined. So you see that there are a lot of lines here. There is a parameter for selecting the lines, and then you see the lines that are selected, and then how the size is defined regarding the match. So this is the number that defines the match. So at the moment we put 4, but we can just parameterize this thing with, I don't know, something like flange division, and then later we define what flange division means in terms of value, thickness, flange division thickness. So this is the first parameter that we will have here. Here is the script somehow that I'm following or I'm defining to then later replace things meshing. So flange division parameter. Then so first we define the flange, then we define also the flange, but not the thickness, but the length. Length. So this is another parameter that we will define in our script. So I'm working here with 2 text files. One, which is the one that I'm creating the general parameters, and then later I can just copy in ANSYS APDL. And the second one, which is the one that I generated from this file by just saying here write-db log file. So with that write-db log file, I have generated this file, which is the one in which I have already put all the parameters that I showed you previously. but here just we see all this scrolling that is not necessary in the script. So based on this script, I'm checking the things that I will later will do automatically. So then, if I remember correctly, we define the web thickness division. With that value of 3. Remember that we can change this later. And then the web length division. With a value of 20. Let me just copy this, that we will use them a few more times. Value of 20. Then we define the rolling par division. Let's call it along, with a value of 3. And then we have defined the rolling par division perpendicular somehow, also with a value of 3. So I have defined the parameters here, and here we have the node that we saw previously, the lines, and now I can just say this is the meshing map, and I just copy these lines that I have here, which I have extracted from doing the meshing with the user interface, and then modify them according to my needs regarding the script. I can just copy this and paste that in my new script, and then we have our script defined with these parameters. So this way we have somehow the cross section. Now we need to define the area. So in this case we go to modeling, create area arbitrary by lines, and then we will select the corresponding lines, and that would create the area that we need. Okay, and then we have the first area. I want to see how that looks in the script. I mean, it's actually not necessary. I can just create all the area and then just copy the lines from this script to my the one that I want to create for automatizing things, and just use them. So I'm going to create all the areas, and then I will show you how the mesh looks like, and then how to create the volume. Okay, I have created all the areas. Now I can just save the file and go to my file to see how the creation of the area works. So it's just we don't need to know all the details here. It's just important that we copy what we actually need. So I can just select all and just move this to my new script that I will later use. So I took the script that already exists, and then I'm adding things, so it would be necessary to clean the script later. Area creation. I'm going to draw a line in here to know that this is somehow the end of what I'm creating now. Okay, now we can just do the matching as well of these areas just by going to the match tool here, mesh tool, and then we want to match area, map it. We just select, I think I can select all the areas, click in OK. Element type 1 is unknown, which are okay, so we need to define the elements that we are going to use in order to create the areas. So just we're going to add here the element that we will use. In this case we're going to use a solid with 20 nodes, so it's just a volume with 20 nodes. Okay, close, and that I think should be enough for I'm going to save to have the division there of the thing that I have done with creating with selecting the type of element. And now I do or try to do the match again. The tool is already open here, so I just select match here, box, select everything, and see if that works now. Okay, element type 1 is solid, which cannot be used with a match command. Matching of area 1 aborted. Okay, so I have some problems for creating the match because since I have defined a volume element, it's not possible to do the match. So I need to extrapolate this volume first, and then later I can do the match. Okay, so I'm going to do that now. Just close this match tool, not extrapolate, extrude the volume. So in modeling, I'm going to write a command, extruding elements. I go to sections, no, modeling, operate, extrude areas by XYZ offset. I prefer that. I can just select all the areas, pick all, and then I can define here that the extrusion is going to be in Z direction with a distance equal to 100 centimeters, for example. I click in OK, and then we put the 3D view, and we see how that looks like. I'm going to save again here, and now we can see what happened on the script when we did that. We did that. So here are the commands of the matching which didn't work. Here is the command for selecting the type of element. We will use that. So I'm going to copy this here to my previous script. So before doing all the things, I'm going to put here something which is selecting the element type, and I copy the line there. Then we have defined the nodes, the connections, the matching of the line, and so on and so forth, creating the areas. And now we put here the extrusion of areas, and we go here to see how that is done. Extruding elements, so it's basically the commands that you see here, selecting everything and then extrusion with a distance of 100. This is another parameter that we should define here, L beam, which I think is defined already here at the beginning, or I delete that. I delete it. So we just create again here the parameter L beam. with 100 in this case. I'm going to save this file, which I didn't save before. I'm going to name it HEM300 version 1. It's the same name that I have here. Okay, so now if we try to do the match, probably that is not going to work that well, because we also need to define the match division of the lines that we see here. So I'm going to put the side view, and here I'm going to say save the file, a comment here. I'm going to write creating line match along Z axis, and I'm going to go again to the matching tool, match match tool, and I'm going to select here the lines set, and with a box I'm going to select all the lines that are along this direction. You see that there are 32 lines selected. I can just click in OK, and then say that we want to divide this into 50 elements, for example. Can just click in OK, and then we see the divisions of the lines. And I'm going to save this again. We go to the script to see how that is done, and it's basically this that we see here. So again, here in my file, extrusion of area, and then creating line match along Z axis, and here we will call this match division length beam, and again we are going to create that parameter here in the upper side of the file. And in this case 50. And I think now we can proceed with the meshing volumes. So now I can go to the mesh tool again, and we have the tool volume there. We can define that this is going to be map in X with map, and then we just say that we select all, and then you see the volume match. Which looks, I would say, relatively good. I can look at the script again here, and then just copy this matching command that we have and put that here in my model in the corresponding position. Then we have the meshing of the volume. Save the file, and that's it. In that way we have created our complex geometry. Something that then all the other things regarding applying the load, something that you would have to explore, and also how to extract the results. It's necessary that you do something there. Something that is very important is that we need to merge what we have created, because probably there are some, since we have many areas, many volumes, maybe they are separated, so we need to merge that. And there is one command which I don't remember where it is. I will have to look at it, but it's just select all merge, or let me just check it. online APDL manage command. So the command is NUMMRG, and then we can just say all, and that should merge everything. And if there are nodes, two nodes in the same position, then there shouldn't be any problem. So that is at least for creating the geometry.